This is SpaceTime Series 28, Episode 80, for broadcast on the 4th of July 2025. Coming up on SpaceTime, a Martian volcano hidden in plain sight, which could help date the red planet. A new study shows that tidal forces from the Sun could have deformed the towering cliffs on Mercury. And the private Axiom 4 mission finally arrives at the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have uncovered evidence that a mountain on the rim of Jezero Crater, where NASA's Mars Perseverance rover is currently collecting samples for possible return to Earth, is likely a volcano. Called Jezero Mons, it's nearly half the size of the crater itself and could add critical clues about the habitability and volcanism of Mars, transforming how science understands the red planet's geologic history. A report in the journal Communications, Earth and Environment underscores just how much science still needs to learn about one of the most well-studied regions of Mars. One of the study's authors, James Ray from Georgia Tech, says volcanism on Mars is intriguing because of the implications it has on habitability. Ray says Jezero Crater is one of the best studied sites on the red planet, but if we're just now identifying a volcano there, imagine how many more could be on Mars hiding in plain sight. Ray first noticed the mountain back in 2007 while looking at low-resolution images of the area. He says it looked like a volcano, but it was difficult to get additional images. Now, at the time, Jezero Crater was still newly discovered, and the imaging focused almost entirely on its intriguing water history, which is on the opposite side of the 60-kilometre wide impact crater. Then, Jezero Crater, due to these lake-like sedimentary deposits, was selected as the landing site for the 2020 Mars Perseverance rover mission, an ongoing NASA project seeking signs of ancient Martian life and collecting rock samples for possible return to Earth. However, after landing, some of the first rocks Perseverance encountered were not the sedimentary deposits that one might expect to find from previously flooded areas, but were instead volcanic. Ray suspected he might know the origin of these rocks, but to make a case for it, he'd need to show that the mountain on the edge of Jezero Crater could indeed be a volcano. And that opportunity presented itself several months after Perseverance landed, when scientists used datasets gathered from spacecraft orbiting Mars to compare the properties of Jezero Mons to other known volcanoes. Ray and colleagues used data from the Mars Odyssey spacecraft, the Mars Reconnaissance Orbiter, the ExoMars Trace Gas Orbiter, as well as the Mars Perseverance rover, to resolve the issue. The discovery makes this crater even more intriguing in the search for past life on the red planet. See, a volcano so close to watery Jezero Crater could add a critical source of heat onto an otherwise cold planet, including the potential for hydrothermal activity, energy that life would use to thrive. And this type of system also holds interest for Mars as a whole. Ray says the coalescence of these two types of systems makes Jezero more interesting than ever, because it means there are samples of sedimentary rocks that could be from a habitable region alongside igneous rocks with important scientific value. Now, if returned to Earth, these igneous rocks could be radioisotope dated in order to precisely determine their age. So dating the Jezero Crater samples could be used to calibrate age estimates, providing an unprecedented window into the geological history of the red planet. This is SpaceTime. Still to come, a new study suggests that tidal forces from the Sun could have helped deform the towering cliffs seen on the planet Mercury. And the privately funded Axiom Space AX-4 mission has successfully arrived at the International Space Station. All that and more still to come on SpaceTime. A new study suggests that massive gravitational tidal forces from the Sun could have deformed the huge escarpment cliffs seen on the planet Mercury. The findings, reported in the journal Geophysical Research Planets, shows that not only was the tiny planet influenced by cooling and subsequent contraction after its formation, but possibly also by tidal forces from the Sun. Right now, the BepiColombo mission, a joint project by the European Space Agency and the Japan Aerospace Exploration Agency, is on its way to the planet Mercury. It'll arrive there in November of next year and could provide new data which will help test this hypothesis. The surface of Mercury is characterized by hills and steep cliffs. See, unlike Earth, Mercury has no tectonic plates that shift against each other. Instead, its crust is similar to a single solid shell. It's thought the hills and cliffs seen on Mercury were largely formed as the planet cooled and shrank over time, after its formation 4.6 billion years ago. Now, as a planet cools, it usually contracts evenly with little sideways motion. However, close observations of Mercury show that its surface not only shrank, but also shifted laterally, causing wrinkles, and these are hinting that more complex internal and external forces are at play. The new study by Lillian Burkhardt and colleagues from the University of Bern suggests that Mercury's surface features were not only influenced by the planet's cooling contraction, but also by tidal forces related to Mercury's orbit around the Sun and its rotation around itself. Scientists have long debated exactly how the fault patterns observed on Mercury, such as cracks and fracture lines in the rocky crust, were originally formed. Until now, it's always been assumed that Mercury's tectonics are mainly the result of cooling and contraction. But the thing is, Mercury's unique orbital behaviour may also be playing a role. This tiny planet in the immediate vicinity of the Sun is exposed to our local star's enormous gravitational field, and thus its tidal forces. And the thing is, Mercury is locked in a 2 to 3 spin orbit resonance. That means it rotates 3 times around its axis for every 2 orbits it makes around the Sun. As well as that, Mercury's orbit's highly elliptical rather than circular, and that causes the tidal forces it experiences to vary periodically over time. The changing forces generate stresses in the crust, gradually deforming the surface and potentially influencing tectonic activity. The authors think these orbital characteristics create tidal stresses that may leave a mark on the planet's surface. To test the hypothesis, Burkhardt and colleagues created physical models of Mercury's interior, both present and in the past, and used these to calculate how the Sun's tidal forces could influence the surface's tensions over the last 4 billion years. Burkhardt says by changing parameters such as the rotational speed and orbital eccentricity of Mercury, they were able to simulate and deduce how the planet's tectonics might have evolved. The results show that the tidal forces of the Sun could have influenced the development and orientation of tectonic features on Mercury's surface over long geological periods of time. Until now, tidal stresses have been largely overlooked on Mercury as they were considered to be too small to play a significant role. But the new results show that while the magnitude of these stresses still isn't sufficient to generate faulting alone, the direction of the tidally induced shear stresses are consistent with the observed orientations of fault slip patterns on the Mercurian surface. And this suggests that tidal stresses may well have influenced the development and shear orientation of tectonic features over long geological timescales. The results illustrate that even subtle forces such as the changing gravitational pull of the Sun can leave a lasting impression on a planet's surface. Burkhardt says that understanding how a planet like Mercury deforms helps scientists better understand how planetary bodies evolve over billions of years. And the findings could also be applied to other planets in order to better understand their geological history and development. This is SpaceTime. Still to come, the privately funded Axiom Space AX-4 mission finally arrives at the International Space Station, and the planet Earth, now at its greatest distance from the Sun, the constellations Regulus and Leo, and one of the biggest known stars in the universe, Antares, are among the highlights of July's night skies on Skywatch. The privately funded Axiom Space AX-4 mission has successfully arrived at the International Space Station for a 14-day stay. The 4-person international team includes American, Polish, Hungarian and Indian crew members. They'll conduct more than 60 scientific, engineering and commercial experiments while on station. It's the 4th privately funded mission by Axiom Space as part of its long-term plans, which will ultimately see it build its own space station in low Earth orbit. The mission was launched aboard the SpaceX Dragon capsule Grace from Pad 39A at the Kennedy Space Center in Florida. However, it's a flight which had been delayed several times. Firstly by bad weather, then by a liquid oxygen leak aboard the Falcon 9 booster rocket, and finally by ongoing concerns over persistent air leaks aboard the International Space Station's Russian modules. NASA put the flight on hold in order to monitor cabin pressure on the Russian side of the space station after it again began venting atmosphere into space. The Russian space agency Roscosmos has been forced to deal with structural cracks and ongoing air leaks in its modules for more than 5 years. As for these latest leaks, Russian cosmonauts inspected the internal bulkheads of the Zvezda module and a connecting port, eventually identifying the possible source of the leak and sealing the hole, which appears to successfully be holding its pressure. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for July on Skywatch. July is the 7th month of the year in both the Julian and Gregorian calendars, and is named after the Roman Emperor Julius Caesar, who was born during the month. Before being called July, the month was called Quintilis, which is Latin for fifth. The addition of the months January and February brought an end to that. On average, July is the coldest month in the year in the southern hemisphere, which is experiencing winter, and also marks the time when Earth is at aphelion, its furthest orbital position from the Sun. Of course, temperatures, or more accurately seasons on Earth, aren't dictated by the distance from the Sun, but rather the length of a day, and hence the amount of sunlight a given part of the Earth receives, which is governed by the tilt of Earth's axis. Consequently, that's why July is on average the warmest month in the Northern Hemisphere, which is currently experiencing summer. Now, during this year's aphelion, the Earth was 152,087,738 kilometres away from the Sun. That's about 5 million kilometres further away than what it is during perihelion, when it's about 147.1 million kilometres away from the Sun. This year's aphelion occurred at 5:54 this morning, July the 4th, Australian Eastern Standard Time. That's 3:54 in the afternoon of July the 3rd, US Eastern Daylight Time, and 7:54 in the evening, Greenwich Mean Time. Over cosmic time, these dates change. That's due to variations in Earth's orbit, such as eccentricity, as well as axial tilt and precession, which all follow regular cyclic patterns known as Milankovitch cycles. Eccentricity involves changes in how elliptical Earth's orbit is around the Sun. None of the planets actually orbit the Sun in perfect circles, although Venus and Neptune are the closest. Instead, they all have elongated orbits which vary over time. As well as that, Earth spins on an axis which is currently tilted at 23.4 degrees compared to the ecliptic, Earth's orbital plane around the Sun. But this angle of tilt also changes over time, influenced by, among other things, the distribution of the Earth's mass. And just like a spinning top, the rotational axis of the Earth also changes its orientation through a process called precession, changing its position in relation to fixed background stars over a 26,000-year cycle. Now, all these effects impact the amount of solar radiation reaching the Earth, what time it reaches the Earth, and consequently the planet's seasonal and climatic patterns. Right now, the Southern Cross is at its highest point in the southern sky, and is pointing directly towards the southern celestial pole. The Southern Cross falls within the constellation Centaurus the Centaur, the half-human, half-horse of Greek mythology, and the creature is holding a bow loaded with an arrow. The Centaur's front legs are marked by the two pointer stars, Alpha and Beta Centaurus. At 4.3 light-years, Alpha Centauri is the second of the two pointer stars from the Southern Cross and is also the nearest star system to the Sun. The Centaur's back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster, visible with the unaided eye from dark locations. Globular clusters are tightly packed spheres containing thousands to millions of stars. They're thought to have all originally been born at the same time from the same molecular gas and dust cloud, or they're the cause of small galaxies which have been consumed by bigger galaxies through galactic cannibalism. Omega Centauri is about 16,000 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Omega Centauri is one of the largest and brightest of the 150 or so globular clusters known to orbit around our Milky Way galaxy. Centaurus was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. Turning to the right or west, and you'll see the constellation Leo the Lion, just above the western horizon. Its brightest star is Regulus, or the Little King, located about 79 light-years away. Regulus, designated Alpha Leonis, is actually a 5-star system, organized into 2 pairs. Regulus A is a spectroscopic binary, comprising a spectral type B blue-white main sequence star, some 4 times the mass and 288 times the luminosity of the Sun, and a faint companion star thought to be a white dwarf, the stellar corpse of a Sun-like star. Spectroscopic binaries are stars that can't be resolved by optical telescopes into 2 separate objects, and can only be separated by observing their individual spectroscopic Doppler shifts as they orbit each other. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive known stars are spectral type M red dwarf stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. So put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which can be about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located further away are Regulus B, C and D, which are dim main sequence stars. At the opposite end of the constellation from Regulus is the star Beta Leonis, or Denebola, the horse's tail. It's also a luminous blue-white star, about half as bright as Regulus, and the 3rd brightest star in the constellation Leo. Beta Leonis has about 1.8 times the Sun's mass and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Delta Scuti type variable star, meaning its luminosity varies slightly over a period of several hours due to pulsations on its surface. Algebra or Gamma Leonis is a binary system with a visible 3rd component. The 2 primary stars are located about 126 light-years away and can be resolved in small backyard telescopes. Both are yellow giants orbiting each other every 600 Earth days. The unrelated tertiary star named 40 Leonis is a yellow tinge star that can be seen through binoculars. The star's traditional name Algebra means forehead. Delta Leonis or Zosma is a blue-white star 58 light-years from Earth. Epsilon Leonis is a yellow giant some 251 light-years from Earth. And Zeta Leonis is an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and located to the south of the primary. The 3rd and faintest star in the system, 35 Leonis, is to the north. Lota Leonis is a binary star system visible in medium-sized backyard telescopes. Located some 79 light-years away, Lota Leonis appears to be a yellow tin star with 2 components orbiting each other every 183 Earth-years. Finally in Leo, let's look at Tau Leonis. Visible as a double star through binoculars, it includes a yellow giant located some 621 light-years from Earth, and binary secondary star 54 Leonis, which is actually a pair of blue-white stars that are visible in small telescopes and located some 289 light-years away. The constellation Leo also contains many galaxies, including the spiral galaxy Messier 66, as well as Messier 65 and NGC 3628, which are known as the Leo triplet. Located some 37 million light-years away, the Leo triplet has a somewhat distorted shape due to gravitational interactions between Messier 66 and the other two galaxies, which are cannibalizing stars from Messier 66. Eventually, the outermost stars may well form a dwarf galaxy orbiting M66. Both M65 and M66 are visible in large binoculars or small backyard telescopes, but their concentrated nuclei and elongation are only visible in larger instruments. Other bright, well-known deep sky galaxies in Leo include Messier 95, Messier 96, and Messier 105. Messier 95 and Messier 96 are both spiral galaxies, each about 20 million light-years from Earth. Both look like fuzzy objects in small telescopes, but display their spectacular structures in larger instruments. M95 is a barred spiral. Another barred spiral, NGC 2903, is thought to be similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also about 20 million light-years away. The constellation also contains the Leo Ring, a cloud of hydrogen and helium gas orbiting two of the galaxies in the constellation. A gravitationally lensed object known as the cosmic horseshoe is also found in Leo. Above Leo, you'll find the constellation Virgo, the Greek and Roman goddess of wheat and agriculture. Virgo's brightest star, Spica, is visible above the western horizon. It's located some 250 light-years away. Spica is Latin for ear of wheat, which Virgo is holding in a hand. Spica, or Alpha Virginis, is the 16th brightest star in the night sky, and is both a spectroscopic binary and a rotating ellipsoidal variable, a close binary system whose stars are not eclipsing but cause apparent fluctuations in brightness because of changes in the amount of light emitting area visible to the observer. Spica's two main stars orbit each other once every 4 Earth days and are so close they're egg-shaped rather than spherical and can only be separated by their spectra. The primary is the blue giant variable Beta Cepheid star. It undergoes small rapid variations in brightness. These are caused by pulsations of the star's surface, thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7 times its diameter. The secondary star in Spica is smaller than the primary, but it's still some 7 times more massive than the Sun and has 3.6 times the Sun's diameter. Turning to the north now, and the constellation Boötes, the herdsman or ploughman. There you'll see the bright orange-red star Arcturus, or Alpha Boötes, just above the northern horizon. It's a red giant located just 36 light-years away, a bloated, aging star some 7.1 billion years old, nearing the end of its life. Although not much more massive than the Sun, it's now expanded out to some 25 times the Sun's diameter and will soon puff off its outer gaseous envelope as a planetary nebula, revealing its white-hot stellar core, a white dwarf, which will then slowly cool over the eons of time. Another bright reddish-looking star, this time in the east, is the red supergiant Antares, meaning the rival of Mars, because of its appearance and location in the sky, which appears to be opposite of Mars in the sky. Antares is one of the biggest known stars in the universe. It's enormous, 18 times the Sun's mass, 10,000 times its luminosity, and 883 times the Sun's radius. As we mentioned in last month's Skywatch, were it placed at the centre of our solar system, its surface would extend out close to the orbit of Jupiter. Despite being some 550 light-years away, Antares is still the 15th brightest star in the night sky. Unlike the Sun or Arcturus, the death of Antares will be far more spectacular. Antares is destined to explode as a core collapse or Type II supernova. When it does so, sometime in the next few 100,000 years, it'll appear as bright in the Earth's sky as the full moon and be quite visible even in daytime. Antares has a companion star, Antares B, a spectral type blue-white main sequence star more than 7 times the Sun's mass and 5 times its diameter. Antares is the heart of the Scorpion in the constellation Scorpius. Below Scorpius is the constellation Sagittarius, the Archer, which points the way to the centre of the Milky Way galaxy. Sagittarius is commonly represented as a winged centaur, pulling back on a bow which is aimed at Antares, the heart of the Scorpion. The centre of the Milky Way galaxy and its supermassive black hole Sagittarius A star lie at the westernmost part of Sagittarius. Sagittarius A star is about 27,000 light-years away and has some 4.3 million times the mass of our Sun. It was in July back in 2016 that the solar system's barycenter moved outside the Sun, where it will remain until 2027. A barycenter is the gravitational centre of mass of a celestial system. For example, in our Earth-Moon system, the Earth and Moon actually orbit each other around a common centre of gravity, a barycenter. Now, because the Earth is so much more massive than the Moon, the barycenter is always inside the Earth's radius. If it were outside the Earth's radius, the Earth and Moon would instead have been classified as a binary planetary system, like Pluto and Charon. The solar system's centre of gravity or barycenter is usually located inside the Sun's radius. After all, the Sun contains over 99% of all the solar system's mass. But actually, the mass of the solar system is orbiting around the solar system's barycenter, which means the Sun also has a very slight spiralling 12-year orbit around the barycenter. And every now and then, when the planet's orbital positions are just right, especially when Jupiter and Saturn are nearest each other, their combined gravitational interactions move the solar system's barycenter ever so slightly outside the Sun's radius. And because Jupiter and Saturn reach this alignment every 11 years, some scientists have speculated whether this could trigger the Sun's 11-year solar cycle. And before you ask, the barycenter isn't named after some guy in a beige safari suit called Barry, but rather it's the ancient Greek word for heavy or centre of mass. We also have 2 meteor showers, both of which peak in late July. There's the southern delta aquarids, which are visible from mid-July to mid-August each year, with peak activity on July the 28th and 29th. The shower originated either from the breakup of what are now the Marsden and Crack sun-grazing comets, or from the parent comet P96 Malkolts. The delta aquarids get their name because their radiant appears to lie in the constellation Aquarius, near one of the constellation's brightest stars, Delta Aquarii. There are 2 branches to the Delta Aquarids meteor shower, the southern and northern. The southern Delta Aquarids are considered a strong shower, with an average of between 15 and 20 meteors an hour between midnight and dawn. Listeners in the southern hemisphere usually get the better show because the radiant is higher in the southern sky. Since the radiant is above the southern horizon for northern hemisphere listeners, meteors will be seen to fan out in all directions east, north and west, with few meteors heading southwards, unless they're really short near the radiant. The northern delta aquarids are the weaker shower, peaking later in mid-August, with an average peak rate of about 10 meteors per hour. Meanwhile, the nearby slow and bright Alpha Capricornids meteor shower will take place from as early as July the 15th and continue until around August the 10th. The meteor shower has infrequent but relatively bright meteors and even some fireballs. It's generated as the Earth passes through a debris trail left by the comet 169P NEAT, which was originally identified as the asteroid 2002 EX12. However, it was shown to be weakly active during perihelion and was then reclassified as a comet. The meteor shower was created about 3,500 to 5,000 years ago, when about half of the parent body disintegrated and fell into dust. The cloud eventually evolved into Earth's orbit, causing a shower with peak rates of about 5 meteors an hour and some outbursts of bright flaring comets, radiating out from the constellation Capricorn towards the south. The bulk of the comet's debris won't be in Earth's path until the 24th century, by which time the Alpha Capricornids are expected to become a major annual meteor storm, stronger than any current annual shower. And now with the rest of the July night sky, we're joined by science writer Jonathan Nally.
G'day, Stuart. Yeah, well, this is a great time of year for stargazing, actually middle of the year, and one of the main reasons for that is that the centre of our Milky Way galaxy is on display, high up in the evening sky. Milky Way, of course, is just our big spiral galaxy seen from the inside. That's where we live. We're about 2/3 of the way out from the middle of it. So when we look in the right direction, towards the centre, we see all those star clouds that form the central bulge of our galaxy. So after the sun has gone down, if you have dark enough sky, skies, and you do need dark skies to see the Milky Way. A lot of people in the city can't really see it too well. You'll see the Milky Way stretching across the sky from east to west, about 8 o'clock or so after it's all dark. The core of the galaxy, where it's thickest, is in the constellation Sagittarius. Now, Sagittarius itself doesn't really grab your attention if you're just out stargazing with your unaided eyes, but if you've got a small telescope, if you turn even a small telescope onto this region, you'll really be in for a treat because there's plenty of stuff to see if you can get some magnification going with a scope, even a pair of binoculars, really. There are plenty of what astronomers call deep sky objects that you can see, things like star clusters and nebulae. Some of the best of them are in Sagittarius and also in its neighbouring constellation, Scorpius. Scorpius actually a bit of an oddity as constellations go because it actually lives up to its name. If you trace out the pattern of its stars, you'll see that it really does look like a scorpion. Now, there aren't many constellations up there that look like what they're supposed to. There's a constellation called Triangulum, which is a triangle. There's the Southern Cross, that looks like a cross. And probably, how many more would there be? There aren't many more really that look what they're... Oh, there's a couple of constellations like Corona Australis and Corona Borealis, which are a sort of a semicircle of stars in each case. They look like what they're supposed to. They look a bit like a tiara, I suppose. But not much else looks like it does. Particularly, Scorpius really looks like a scorpion. The brightest star in Scorpius is a star called Antares, and that name means the rival of Mars. Antares, the rival of Mars. This is because it has an orangey red colour, just like Mars, and it's reasonably bright, just as Mars often is. And when you see them not far apart from each other, because Mars moves across the sky, so when it comes in close-ish to Antares, then you see that they look very, very similar. Antares is actually a binary star system. Its main star is a red supergiant. It's about 15 times the mass of our Sun, but it's so big that if you placed it at the centre of our solar system, it would reach out halfway to between Mars and Jupiter, so out near the asteroid belt. That's how huge it would be. I mean, that's, what we're talking about there, more than 150 million kilometres or something away, whereas our Sun is, about 1 million kilometres wide? So it's an enormous, enormous star. There aren't many very bright stars around at mid-evening time in July, at least for where I live, sort of in the southern hemisphere. But those that are visible are in the north, as seen from here. You've got the star Vega, which is the brightest star in the constellation Lyra, which is named after the musical instrument, the lyre. In the northwest, there's another star called Arcturus, which is the brightest star in a constellation that most people have never heard of, called Boötes, which stands for the herdsman or the ox driver. In the other side of the sky in the northeast, you've got a star called Altair, which is the brightest star in the constellation of Aquila, the eagle. And way, way, way down in the south, there's a star called, one of my favourite stars, called Achernar. And that star forms the end of the constellation of Eridanus, the river, which is a hugely long constellation. It's a long, thin constellation. It winds its way up down from the sort of, I think it's around the celestial equator, way down towards the very far southern sky. And while we're down in the southern part of the sky, we do have the Southern Cross up at this time of the year. It's about as high as it gets, really. Sort of a little bit, if you look straight south and then just go up and a little bit to the right, you'll see the Southern Cross. And you'll see also the two pointers stars, the famous two pointers, Alpha and Beta Centauri, just a little bit way to its left. Like Sagittarius and Scorpius, the Southern Cross and the area around it are also within the Milky Way, so it's within our galaxy. So there are lots and lots of great deep sky objects to see if you have binoculars or a telescope. Just next to the cross, for instance, there's a cute little star cluster called the Jewel Box. And in the constellation next door, Centaurus, there's a fantastic star cluster, what they call a globular star cluster. It's called Omega Centauri. Although best seen with a telescope, Omega Centauri, through which it looks really tremendous, you can actually see it with the naked eye. It's so big and bright intrinsically that even though it just looks like a faint, fuzzy star, what you are seeing is an enormous collection of 1 million plus stars all formed into a ball shape, thousands and thousands of light years away. It really is quite spectacular. If you can get a small telescope onto that, it's really, really good. So turning to the planets now, let's see what's up. Well, after the sun has set, we've got Mercury, which can be seen above the west-northwestern horizon, at least as seen from down here in the southern hemisphere. It just looks like a small, bright star. So it's sort of in the evening dusk, when the sky's still a little bit orange from the sunset. You should be able to see Mercury above the horizon there. Higher up in the sky and a bit more to the northwest, you'll find Mars. Mars looks like a star too, I guess, but it has a very distinct red colour. It really is quite prominent. If you've managed to identify that star I was talking about earlier, Antares, the rival of Mars, and you can look at that one and then look at Mars, the planet, compare the two, and you'll see why they are considered to be very similar in appearance, because they do look very much like each other. Next, we've got Saturn, which rises in the east about 10:30 p.m. It's fairly bright at the moment, fairly easy to spot. There aren't too many other bright stars around that you can mistake for it, so try and see if you can spot that one. And now, when I say it rises at 10:30, don't go out expecting to see it at 10:30. That's when it's on the horizon coming up. So give it an hour or two. So midnight it should be up fairly high enough to try and see it. The other two bright planets that you can see with the naked eye are their early morning affairs at the moment. So you've got to get up before dawn or be very late to bed, a night owl. You've got Venus, which is rising in the northeast at about 4:45 in the morning. It's big and it's bright and you just can't mistake it for anything else. It's the third brightest thing in the sky after the sun and the moon. So you just can't mistake Venus. And Jupiter is the last one. It follows Venus into the morning sky about half an hour later, about 5:15. It's also very, very big and bright, but not quite as bright as Venus. And that, Stuart, is the night sky for July.
That's science writer Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.